Two spacecraft launched in 1977. Older than the internet, older than personal computers, are still sending data home from beyond the edge of the solar system. And the only reason they're still alive today isn't luck. It's a series of engineering decisions made decades ago that most modern spacecraft don't even use anymore. Voyager 1 and Voyager 2 were launched 16 days apart in August and September 1977. Their original mission was to fly past the outer planets, Jupiter, Saturn, Uranus, and Neptune, taking advantage of a rare planetary alignment that only occurs roughly every 176 years. That grand tour mission succeeded beyond expectations, but what nobody fully anticipated in 1977 was that these spacecraft would still be functional nearly 5 decades later, now operating in interstellar space, beyond the heliosphere, the protective bubble of solar wind and magnetic field that surrounds our solar system. Voyager 1 crossed the heliopause, the boundary between the solar wind and interstellar medium, around 2012, confirmed by NASA. Voyager 2 followed in 2018. As of 2024, Voyager 1 is more than 24 billion kilometers from the Sun, making it the most distant human-made object ever. Voyager 2 is over 20 billion kilometers away. At those distances, a radio signal traveling at the speed of light takes over 22 hours to reach Voyager 1 and roughly 18 hours to reach Voyager 2. So how are they still working? The first answer is nuclear power. Both Voyagers are powered by radioisotope thermoelectric generators, or RTGs. These devices use the heat produced by the natural radioactive decay of plutonium-238 to generate electricity through thermocouples. No moving parts, no solar panels needed. Plutonium-238 has a half-life of about 87.7 years, meaning it loses roughly half its heat output over that period. The Voyagers launched with RTGs producing about 470 watts each. By 2024, decades of decay has reduced that output considerably. Each spacecraft now generates somewhere in the range of roughly 230 to 250 watts or less, and the power continues to decline. This declining power is the central survival challenge. As power drops, NASA's team has had to make hard decisions. Shut down heaters, turn off instruments, reduce operations. In 2023, NASA engineers discovered that Voyager 1 was sending back garbled data, a serious malfunction traced to a single corrupted chip in the flight data system. The engineering team, working with signal delays exceeding 22 hours each way, spent months diagnosing the problem and devised a creative fix. They relocated the affected code to different memory locations. In November 2023, Voyager 1 resumed sending usable science data. That repair, executed across interstellar distances with 1970s hardware, is one of the most remarkable feats of remote engineering in the history of space exploration. The second reason they survive is redundancy and conservatism in the original design. Engineers in the 1970s built the Voyagers with backup systems for critical components. They also used components rated to survive radiation and extreme cold. The spacecraft were not designed to be cheap. They were designed to work. That philosophy extended to the onboard computers, which use a combination of systems for command execution, attitude control, and data handling. The third reason is the Deep Space Network, NASA's global array of large radio antennas, located in California, Spain, and Australia, designed to communicate with spacecraft far from Earth. Without the DSN's large dish antennas and sophisticated signal processing capability, the faint whisper of data from the Voyagers, transmitting at roughly 160 bits per second from Voyager 1, would be undetectable. To put that in perspective, a standard modern home internet connection can move millions of times that amount of data per second. The Voyagers are whispering across interstellar space, and we built ears sensitive enough to hear them. The fourth reason is the team. NASA's Voyager mission has maintained a small group of engineers and scientists who understand these spacecraft at a level of detail that can't be learned quickly. Some team members have worked on the mission for decades. When the 2023 Voyager 1 computer anomaly emerged, it was that depth of institutional knowledge, combined with old documentation and careful analysis, that made the repair possible. How much longer can they survive? NASA estimates the RTG power will drop below the level needed to operate any science instruments by the late 2020s. At that point, the spacecraft will continue flying silently into interstellar space, no longer transmitting data, but still moving outward at roughly 17 kilometers per second for Voyager 1. They'll drift through the galaxy for millions of years, carrying the golden records, each containing sounds and images of Earth, into the dark. That golden record detail isn't just poetic. It was a genuine scientific and cultural decision. The records were included with the understanding that in the far future, either another civilization or our own distant descendants might find them. Follow for more space stories that connect real engineering to the impossible. And tell me, knowing that Voyager 1 is whispering data home from interstellar space right now, does it make you feel small or does it make you feel proud?